Okay, so most of the communication will be done through diagrams. I think a well-made diagram can speak volumes, and in order to do so, I need to explain what kind of system that I'll be using, what kind of symbol I'll be using, and what these squares, circles, and rectangles mean. Um, so before we go through there, let's see the big picture. So in today's episode, we are going to make this sound at the end. Okay, so that's our goal. To start, first we have to make an instrument. Uh, think of it as a kind of like a choosing a software instrument in your DAW, or perhaps making a generator module, putting a generator module in modular rack. We need a sound. We need a thing that actually creates a sound. So first step is we're gonna make an S object, a synthesizer object in SuperCollider language. It's synth-def. So first we are going to make a synth-def, and I can name it. I'm gonna name it as an eye blipper, and it creates this kind of sound. Okay. So we make a little synthesizer, and then next step is sequence them. Next step is to make a pattern using this synthesizer, and it's gonna be called as a loop. Okay, so whenever you see an L sign, it means that it's being sequenced, or it's being patterned, or it's being repeated with certain changes. So here is a loop that uses the eye blipper synthesizer, and depending on the parameter you choose, the synthesizer can be played short, long, high, or low, right? So here is the one loop that uses the S eye blipper. Okay, so make a synthesizer and make a loop. Next step is elaboration. So now we have a simple synthesizer and a sequencer. We gotta make a little function. So first thing we're gonna do is create a interesting ways to change the parameters of the loop and a synthesizer. So we are going to use the randomization, the R's on here, and then every time we press a note, it's going to create a different kind of sound. So in a way, we are going to make a preset, and in my series, I'm gonna call it as a function. So whenever I use you hear me say like it's a function, or like a f, kind of think of it as a kind of like a very I don't know, clever way of using a preset. So basically, whenever I run a function, it's going to set the parameter of the synthesizer in a interesting way. In our case, every time I run or I press play for the function, it's going to randomly choose parameters, and then it will create a different sound. So here's an example of running the same function 3 times, but because of this and the parameter change, we are going to hear 3 perhaps different sound. and sound 2. And sound 3. Right. So that's your step 3. It's elaboration and making a function. Last step is to make music, right? In our case, for this example, we're going to improvise, and the improvisation is done by basically running the function in different timings and basically in different timings. So my approach in this short piece is run the lines below, and I'm gonna show what that means, and improvise the timing, and that's what you actually get, what you get for and this is what the result that you heard in the first audio example. Okay, it's the first audio example, what you heard in here. Okay, so to recap, right, for our series, I'm gonna go through these 3 steps. First, make an S, a synthesizer, then put that S into the L, a loop, okay, to sequence them to make some a series of events, and then control those synthesizers and a loop using a function. And function often defines the a definition of a condition. So you can kind of think of it as a kind of like a preset. So make a software instrument, and then make a sequencer, and define some nice sounding presets. Okay, so that's kind of what we are going to go through in creating music for this series. Now, how we interact, okay, we as a human or we as a performer interact with the instrument, there are a few ways. So I can interact with the code, I can interact with the synthesizer by directly changing the code. Okay, that's what I did right in here. I'm gonna just run the code, and it's going to make a sound at my command. Okay, now this example also uses the random number. Computer chooses certain conditions or the parameters. So in addition to me as a human creating an input to the instrument, computer itself also changes the parameters of the instrument itself by using some random functions. Now, in other series, I'm also going to show you another way of interacting it. Instead of using a code, we can interact with the GUI, right? Just like any other DAWs or plugins. So human can interact with the instrument using a GUI and a mouse click. Now, when we create a music with the DAW, what we're doing is we are making us scheduled events, right? At measure 1, do this, measure 3, do this, measure 4, do that. So we can also create a little clock or schedule to trigger or change the parameters of the function in a specific time. But today's example, we only use the human changing the code and the computer randomly changing the code. Okay, so in next video, actually, I almost forgot. This is actually the most important one. So before we delve into the instrument itself, let's go over the terms that we are going to use. So every block diagram, okay, in addition to this S, L, and F, you are going to have a block diagram. Okay, so think of the arrows, the lines, as a patch cable. It connects an output of a certain thing into an input of certain things. So every time you see a cable, it's a one-way street, and it carries a signal from one object into another. Okay, so in here, every instrument that we are going to build and use will have an output, and this is basically your speakers. Whatever that's connected to the out will be what you're going to hear. If you're not, everything else is connected to something else. Whatever that's connected to the output and out will be what you're going to hear. Now, a lot of the names that you're going to see here will be the equivalent of the SuperCollider language, but I will explain what they usually mean. Now, most of the time you're going to see this big rectangle and small rectangles. Big rectangles represent a UGen, a unit generator, and this is an audio unit that does a very specific thing. For example, sine wave could be a UGen, a low pass filter could be a UGen, delay could be a UGen. So SuperCollider works, and a lot of synthesis design works by connecting those unit generators in a unique way, right? So in our case, as you will see later, an impulse generator is sending an output to the BPF, which stands for band pass filter, right? It's like kind of having like a little module that creates a sound. You patch the output of that into the input of the filter. And when you have a filter, in addition to getting a sound, right, you can control a frequency. So whenever you see the line going in, you will, sometimes you're gonna see, most of the times you're gonna see a line with a label. That label is indicates in which parameter this signal will be going into. So for example here, if I have a BPF and an impulse connected and impulse going into the in, that means that my impulse generator's output, the sound, will go into the input of the bandpass filter. Now, something else is going into the frequency. So in this case, the frequency represents the center frequency of the bandpass filter, and that comes from here. I'm gonna just follow back, and it looks like the signal is coming from the combination of an ACF and something coming from here, like this. Okay, so now there are small rectangles that you're gonna be seeing, and it could mean three things. If you see a rectangle with italics and with some kind of a name like this, A-freq, A-attack, or ACF, that means it's an argument. Think of this as a kind of like a little knob or slider in your plugins or in your software instrument or in your modular. Okay, so this is where you as a human interact with the instrument. You change something in here and sound will change. You change something in here and something in this signal path will change. This is where you as a human change the parameters. Now, when computer changes it, it can be a lot of things, but in our in our series, we're gonna use a lot of random number generator. So whenever I use a random number generator, you're gonna see a small rectangle with the R on it. So R means random stuff. Okay, so here you're gonna see later is that here if you see an R 0.4 comma 0.7, it means that every time something runs, computer is going to pick any number between 0.4 and a 0.7. Okay, so a random number actually gets a special symbol with a kind of a grade feel. Sometimes you're just gonna see a number, a single line, so it could be like any number, like here. Okay? That's a constant, right? So instead of actually changing things like random number or an argument, we can just assign a single number which will not change over the course of time. Okay, that's a constant. Okay, now your signal does not have to go just one unit to another. It can duplicate. So whenever you see a black circle, that means the signal is being splitted. Okay, so your argument, for example, can control in here both UGen and this circuit called arithmetic. So signal can be duplicated in many paths, and in your diagram, whenever that actually happens, I'm gonna use a little dark circle to indicate that the signal is going into uh, multiple directions. Now, arithmetic, the blank circle will be the mathematics, multiplication and addition and everything else, subtraction and divisions. Because digital music, in essence, is doing math. Because let me say this. Okay, so in digital music, your sound is represented as a number, and because sounds are represented as a series of numbers, we can do math, right? You can just add one signal to another, and that would be a signal A plus signal B. And if you can add them, you can subtract them, multiply them, and divide them. So in a lot of sound designing, in a lot of instrument designing, math is going on all the time. Okay, so we are going to see a lot of multiplications, additions, and subtractions, and sometimes divisions. Okay, so those are the symbols that we are going to use. Something that we're gonna be able to control: arguments, random numbers, and constant number. Those are the things that we are going to control. This is where we tweak the knobs, that we actually move the sliders, and then it's going to change something in a signal path. Okay, and the signal path consists of the UGENs, which does a specific things in audio, like a filter, delays, reverb. Those are all UGENs. It could be like kind of like you can think of it as a kind of a plugin. Okay, and then the way to communicate and customize those signal paths is by multiplying those signals, splitting those signals, and also doing some kind of math in their signal path. And what you're actually going to hear is the whatever that's connected to the output. Okay, so that's how we are going to explain the instrument design, and how we're going to actually explain how the instruments is designed, but also those instruments are being sequenced and categorized and and made into some sort of presets. Okay, and then we're going to talk about how those instruments will be interacting with the us as a performer, or interacting within itself using the algorithms and the random numbers and any other means possible. Okay, so in next video, we're gonna start to talk about the details of the instruments, why and how of the choices that I make in these particular examples.